Recently, residents of Kamchatka awoke to the tremors of a powerful earthquake. A magnitude 7.2 quake echoed the devastating event of the previous summer, yet Russian scientists issued alarming warnings. They suggest this tremor could be a precursor to an even more destructive earthquake. In the 24 hours following the initial shock, seismic stations recorded 33 aftershocks, each reaching up to magnitude 6. The earth beneath Kamchatka has been restless for nearly 4 months, with cracks appearing in school walls, dormant volcanoes stirring after 5 centuries of silence, and the tectonic plates continuing their slow but relentless shift toward the ocean. Experts from the Institute of Volcanology and Seismology now warn that within the next 2 years, a quake of up to 9 on the Richter scale could occur. Kamchatka has become the epicenter of a seismic upheaval that challenges established scientific laws. The ongoing activity is forcing scientists to revise textbooks and develop new theories on the fly as the region's behavior defies traditional understanding. This heightened seismic activity is not confined to Kamchatka alone. It spans the entire Pacific Ring of Fire. Specialists fear that this chain reaction could trigger a series of powerful earthquakes across Japan, the United States, and other vulnerable zones. The question remains, why has Kamchatka been so restless for nearly 4 months? What new insights have scientists gained from recent quakes, and what do their forecasts indicate for the future? On September 19th, 2025, at 4:28 in the morning local time, Kamchatka was jolted once again. A magnitude 7.2 earthquake shook the region, reminding the world of the devastating events of the previous year. That initial disaster was merely the beginning. The subsequent seismic activity transformed the peninsula into an open-air laboratory of tectonic processes. The epicenter of this latest quake was just 93 kilometers from the regional capital, with the focus at a depth of 123 kilometers. Residents were stunned as chandeliers swayed, furniture trembled, and airport information displays rocked. Yet scientists describe this as part of a unique seismic phenomenon. Within the first day, seismic sensors detected 33 aftershocks, each up to magnitude 6. The ground beneath Kamchatka seemed unable to settle, with new tremors occurring every few hours. On September 21st at 4:13 Moscow time, another quake of magnitude 6.1 struck 108 kilometers from Petropavlovsk-Kamchatsky. The following day, a magnitude 6 tremor hit again, keeping the region in a state of constant seismic activity unseen in decades. Most astonishingly, experts from the Institute of Volcanology and Seismology in Iran made a startling prediction. They suggested that the September earthquake was not merely an aftershock, but a foreshock, an indicator of an impending, even more powerful quake, potentially reaching magnitude 9. This forecast was based on precise calculations, revealing that the Awachan Bay region had accumulated enough seismic energy to produce a quake of approximately magnitude 8.5 to 8.7. The September tremor could have been the trigger that unleashed this colossal force. Meanwhile, local schools showed visible signs of the ongoing seismic stress. Deep cracks appeared on walls and ceilings, a stark reminder of the Earth's restless energy. The region's seismic activity continues to challenge existing scientific principles, prompting experts to rethink how earthquakes develop and propagate in this volatile zone. In some buildings, the damage was so severe that they had to be temporarily closed. The most affected was school number 34, where cracks spread across load-bearing structures. Even well-constructed, reinforced buildings couldn't withstand the relentless seismic forces. Residents of Kamchatka reacted differently to the tremors. Some panicked, hurriedly gathering belongings and preparing for evacuation, while others tried to face the situation with humor. Yet despite these varied responses, the scale of the ongoing events prompted the regional governor to put emergency services on high alert. Widespread inspections of buildings and infrastructure across the region soon commenced. To understand why Kamchatka became the epicenter of such seismic chaos, one must look beneath the Earth's surface where a hidden battle unfolds between colossal tectonic plates. What is happening there is no random series of tremors, but the inevitable outcome of a powerful geological process spanning millions of years. Academician Valentin Mikhailov from the Institute of Earth Physics explains simply, the Tikhookyanskaya plate is slowly moving toward the Okhotsk plate, which underlies Kamchatka. However, these plates cannot slip past each other because their contact zone is locked tight. Imagine two enormous crustal slabs pressing against each other with immense force, yet unable to move. A buildup of stress and deformation occurs at the contact zone. As the Tikhookyanskaya plate continues to exert pressure, the eastern coast of Kamchatka gradually recedes. This process can last decades, until the accumulated stress reaches a critical threshold. At that point, a sudden release, known in geology as a seismic slip, occurs, causing the plates to shift abruptly and unleashing stored energy. The surface of these plates features irregularities called tectonic faults, where movement is restricted and stress accumulates over time. When an earthquake strikes, it often results from the rupture of one such fault. Kamchatka's recent earthquake was notable because it involved the destruction of at least 3 tectonic faults, making its epicenter uniquely complex. Scientists also found that the powerful July quake, registering around 8.8 on the magnitude scale, partially released the energy accumulated in the region near Korea. However, the relaxation process can take months, during which additional tremors, possibly even stronger, may occur. The director of the Geophysical Service of the Russian Academy of Sciences warned that these events challenge traditional seismic theories, indicating that science must confront phenomena that do not fit existing models. The consequences of the Kamchatka earthquake are so extensive that some experts compare them to the catastrophe that devastated ancient Pompeii. Academician Arkady Tishkov stated that the seismic shifts could cause entire cities to sink beneath the waves. Unlike the localized destruction in Pompeii, which was confined to a specific region, the current seismic activity threatens a much larger sub-regional area, highlighting the profound and far-reaching impact of these geological processes. The numbers are staggering. The southern part of Kamchatka has shifted nearly 2 meters eastward, moving from the mainland toward the ocean. But this is only part of the story. Not only has the peninsula changed position, but it has also experienced a slight subsidence in elevation. Remarkably, this massive seismic event affected even Vladivostok, located thousands of kilometers away, which shifted by about 5 centimeters. Such a distant impact underscores the immense power of the underground forces at play, influencing not just Kamchatka but also the entire Pacific Plate. For comparison, a similar 2-meter displacement was recorded in Japan's Tohoku region, following the devastating earthquake of 2011, which caused the Fukushima nuclear disaster. Visualizing such a scale of geological upheaval is challenging, but Kamchatka's recent event ranks among the most significant modern tectonic shifts. Geologists warn that the tectonic movements are likely to continue, potentially leading to substantial restructuring along the entire eastern coast. This ongoing process could cause not only tsunamis but also vertical land movements, with land rising or sinking in various areas. The repercussions extend to the Kuril Islands and the coastal seas of the Sea of Okhotsk, where seismic activity may trigger further uplift or subsidence, resulting in the formation of new islands or the disappearance of old ones. Such powerful earthquakes inevitably alter coastlines, which are critical for navigation, fishing, and port infrastructure. Ports built along previous shoreline lines might become obsolete or unusable, forcing a reassessment of maritime routes due to changing depths and currents. Interestingly, the modern town of Severokurilsk remains relatively safe. Situated more than 20 meters above sea level on higher ground, a precaution rooted in the tragic history of the year 1052, when a tsunami nearly wiped out the old town. The new settlement was constructed on elevated terrain, well away from the direct impact zone of future waves. These intense seismic events have also awakened dormant volcanoes, some dormant for centuries. For the first time in over 600 years, the Kroshnikov volcano, silent since the 15th century, erupted, marking its debut in recorded history. This eruption was so significant that it was captured by satellite imagery, an extraordinary feat for modern volcanology. Scientists remain vigilant about the Podonovich Glacier, as lava flows could melt it, potentially blocking the only federal highway connecting the north of Kamchatka to the rest of the region. Such an obstruction could have long-lasting ecological consequences, disrupting transportation and supply chains. Volcanic eruptions can also cause environmental pollution and influence global temperatures, with ash and gases spreading into the atmosphere. The impact of these seismic and volcanic disturbances extends beyond land, affecting oceanic ecosystems. Tsunamis have disrupted traditional currents and temperature patterns in coastal waters, threatening marine life and local fisheries. In reality, the events on Kamchatka mark just the beginning of a broader planetary awakening, an increase in global seismic activity reaching unprecedented levels. What occurs in one part of the Earth can trigger a chain reaction elsewhere, highlighting the interconnected and dynamic nature of our planet's tectonic system. Every day, our planet experiences hundreds of thousands of earthquakes. Fortunately, most are minor and cause little damage, but destructive tremors with magnitudes of 6 or higher occur roughly once a year, making their prediction extremely difficult. Russia finds itself in a particularly vulnerable zone. Besides the Kamchatka Peninsula, Sakhalin, and the Kuril Islands, other seismically active regions include the Ekaterinburg-Khabarovsk area, the Baikal region, the North Caucasus, and Crimea. There are no completely safe zones. Seismic activity can be felt even in Moscow, as in 2013, when tremors from the Kamchatka quake were noticeable. The most earthquake-prone areas include the Caucasus, Altai, Sayan Mountains, Sakhalin, and Kamchatka, where seismic events of up to 8 on the Richter scale are possible. Residents of these regions should always be prepared for such emergencies. Of particular concern is the Baikal region, which last experienced a strong quake in 2008 near the settlement of Kultuk, with a magnitude of 8 and tremors reaching 6 in Irkutsk. Statistically, such events recur approximately every 25 years, implying the next could happen within the next decade. Recently, oceanographic institutes reported on the likelihood of similar or even stronger earthquakes hitting southern Russia. In late August, a 5.5 magnitude quake occurred off the coast of Dagestan, with its epicenter about 50 kilometers from Derbent. Its tremors were felt in Astrakhan, Chechnya, and even reached Krasnodar and Adygea. Forecasts suggest that the probability of further earthquakes in Dagestan and neighboring areas remains, although their maximum energy is limited. Unlike Kamchatka, where larger quakes are common, southern Russia typically experiences moderate events with magnitudes up to 6 or 7. Underwater earthquakes that displace vast water masses can trigger tsunamis. This was evident after the recent powerful quake in Kamchatka, which caused a series of tsunamis affecting the Sakhalin and Kuril Islands. It is a common misconception that tsunamis only threaten Russia's Far East. However, they can occur in the Black and Caspian Seas as well. Historical records show that near Yalta in 1927, several earthquakes generated tsunamis with waves reaching several meters along the Crimean coast. Over the past century, the Black Sea has repeatedly experienced tsunami-like waves, with heights of 2 to 3 meters, indicating that such events are possible in these waters both now and in the future. While the risk of tsunamis in these seas is lower than on the Kamchatka coast or the Kuril Islands, the higher population density along the Black Sea coast, especially during winter, increases the danger. Even waves of just 2 meters can cause significant damage and human casualties in densely populated areas. The seismic activity along the coastlines of the Black Sea is concentrated in earthquake-prone zones, where even a modest wave can reach land within minutes. Notably, neither the Black Sea nor the Caspian Sea currently possess dedicated tsunami warning systems or regular monitoring efforts. Presently, scientists observe an increase in seismic activity across the entire Pacific Ring of Fire, with the Kamchatka Peninsula remaining a particularly volatile area. The region's tension has not yet fully eased, while the main seismic stress in the Chigi region has diminished. The northern and southern parts of the peninsula still face the threat of significant tremors. A particularly dangerous zone is near Ust-Kamchatsk, where the Kuril-Kamchatka and Aleutian Island arcs converge, an area known for generating some of the world's most powerful earthquakes. To improve safety, plans are underway to establish a new seismic monitoring system in this region, building on the successful network already operational in Petropavlovsk-Kamchatsky. Seismologists are developing innovative forecasting methods based on Kamchatka's seismic data, aiming to automate the detection of early signs of earthquake preparation. Such advancements could enable medium-term predictions with a lag time of roughly 2 to 4 weeks. Despite these efforts, the future of Kamchatka remains uncertain, as experts note that traditional seismological laws do not always apply in this complex environment. The unpredictable nature of seismic activity on the peninsula compels scientists to revisit fundamental principles of earthquake science. Nonetheless, it is clear that Kamchatka has become a testing ground for new predictive technologies. Earthquakes of magnitude greater than 8 are likely to occur more frequently, not only here but potentially across the globe. That concludes this overview. If you found this information insightful, consider engaging with the content through further reading or discussion.